all the elements of the domain are uniquely mapped with the elements of codomain. So therefore this is a function from A to B. A relation from a set A to set B is said to be a function. How they are related? If every element of a set has one and only one image in the set B. All the elements of A are used only one time. So there is one-to-one mapping. Therefore this is a function. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So in my previous class we have discussed regarding the Cartesian product and relation. Now in this section I am going to explain regarding the definition of a function and the types of function. Now in the previous class we have studied regarding a relation. Now let us, by knowing the relation, we will define the definition for a function. What is a function? First of all, it is a relation. A function is nothing but a relation from a set A to set B. A relation from a set A to set B is said to be a function. How they are related? If every element of a set has one and only one image in the set B. Every element of a set A has only one and one image in the set B. For example, if A comma B and C comma D, these are the two relations, A comma B and C comma D, then they are represented like this. Suppose this is A and B. If A contains A and C and the elements of B are nothing but B and D. How they are related? A to B is related and C to B, D is related. So we can say F is a function from A to B, denoted as F from A to B is a function. See here. So every element of A has association only one time with the element B. Every element of A is associated with only one element of the set B. Now therefore this is called as a function. Now how to define a function? A relation, this is a relation A to B and C to D. A relation from a set A to set B is said to be a function if every element of a set A has only one and one. Every element of a set has one and only one image in the set B. So therefore these are called as the images of F, and these are called as the pre-images of the set under F. So images and pre-images. And so you already know regarding this, all the elements of the set A are called as the domain. These are called as domain, and the elements of the set B are called as codomain. This is called codomain. The elements of the set A are called the domain and they are called as the codomain. Now a function F is a relation from a non-empty set A to a non-empty set B such that the domain of A and no two distinct ordered pairs in F have the same element. The domain of A and no two distinct ordered pairs of F have the same first element. This is very important concept. Now if F is a function from A to B and A comma B belongs to F, if A comma B belongs to F, A comma B belongs to the function F, then F of A is equal to B. We can write this implies function of A is equal to B. If suppose if C comma D belongs to F, means we can write F of C is equal to D. The function of C is equal to D. So if A comma B belongs to F, then we can write F of A is equal to function of A is equal to B, where B is called the image of A under F. This B is called the image of A, and similarly D is called the image of C under the function F. And here the element A and C are called the pre-images, whereas the element B and D are called as the image. So a function F from A to B is denoted as F from A to B. This is how we are going to represent. F from A to B is called a function. That's all. So the very important definition is A relation f from a set A to set B is said to be a function if every element of A has one and only one image in the set B. One and only one image in the set B. Okay, right. Now, let us consider an example. Let n be the set of natural numbers and the relation R be defined on n such that the relation R is equal to x comma y such that y is equal to 2x and x comma y belongs to n. So, we have to write what is the domain, what is the codomain and the range of R. Is this relation a function? We have to verify. Now, what is given here? Given x comma y such that y is equal to 2x for all x comma y belongs to the set of natural numbers. Okay. Now listen to me. Suppose if we take x is equal to 1. When x is equal to 1, y is equal to 2 into 1 is 2. So we are going to get the elements as 1 comma 2. Now suppose if x is equal to 2, what is y? Y is equal to 2 into 2 is equal to 4. So the elements are 2 comma 4. Similarly, if x is equal to 3, y is equal to 2 into 3 is 6. The elements are 3 comma 6. So suppose if x is equal to 4, we will get 2 into 4. This is equal to 8. So here this is 4 comma 8. That means here let me represent A and B. So this is A and B, a function, whether it is function or not. So A contains 1, 2, 3, 4. The elements of A are 1, 2, 3 and 4. B contains 2, 4, 6, 8. Now how they are related? So 1 to 2, then 2 to 4, then 3 to 6 and 4 to 8. So definitely f from A to B is a function. So this relation f from A to B is a function. This is a function. So the relation given by y is equal to 2x under x comma y such that xy belongs to n is a function. This relation is a function. See here, all the elements of A is associated with the elements of B by unique time. There is only one mapping. So all the elements of A are used only one time. So there is 1 to 1 mapping. Therefore, this is a function. Right. Now, what is to write? The domain and the codomain. So this is nothing but the domain and this is nothing but the codomain. Okay. Now, and the range. First, so how to write the domain for this? Here, the domain is nothing but the set of natural numbers. So therefore, I will write the domain of the given function. The domain is equal to set of all natural numbers. Set of all natural numbers n. Domain is the set of all natural numbers n. Now, what is codomain? Codomain is also the set of all natural numbers. Codomain is also equal to set of all natural numbers. Codomain is also the set of all natural numbers. Okay. Now, what is the range? This is the range. Here, all the elements 2, 4, 6, 8 are in the form of even number. So therefore, the range of this is the set of even numbers. Range is equal to set of all even numbers. This is the range. Set of all even numbers. So here, every natural number is related to another natural number by unique time. So therefore, this is a function. Okay. Now let me explain. What is the function given? Y is equal to 2x. Let us take x is equal to 1, 2, 3, the natural numbers. Then you are going to get the elements of B as 2, 4, 6, 8. Map it. So then clearly this is a function because there is 1 to 1 mapping. All the natural numbers are related with another natural number by a unique time. So the domain is nothing but the set of all natural numbers. And the codomain is also set of all natural numbers, whereas the range is the set of all even numbers. Set of all even numbers. That's all. Now, hope you followed. Now, let us come to the next problem. Now, what is the problem? Examine each of the following relation given below and state in each case giving reason whether it is a function or not. So, we have to verify whether the given relation is a function or not. Okay. Let us come to this. See here, the first example, r is equal to 2, 1. So straight away we can say all the elements are unique associations. Here 2 is related to 1, 3 is related to 1 and 4 is related to 1. So here Let us write this as A and B. So what are the elements we have in set A? 2, 3 and 4. Here it is 1 and 2. Now 2 comma 1, 2 to 1 and again 3 to 1 and again 4 to 2. See here clearly f from A to B is a function. F from A to B is a function. We can say this is a function. So this is the diagram. Let us represent the elements of set A is 2, 3, 4 and B is equal to 1, comma 2. How they are related? 2, comma 1, 3, comma 1 and 4, comma 1. See, all the elements of the domain are related uniquely with the elements of codomain. So clearly this is a function. See, there is a mapping from 2 to 1, 3 to 1 and 4 to 1. All the elements of the domain are uniquely mapped with the elements of codomain. So therefore this is a function from A to B. Every element of the domain is uniquely related to the elements of a codomain. Therefore this is a function. Now let us come to the second one. Now let me check this. The same. Write on this A and B. This is F. So A, what is this contains? 2, 3. And here the elements are 2, 3 and 4. Now let us map this. 2 to 2, 2 comma 2. Again 2 comma 4, 2 comma 4. Again 3 to 3. Again one more element 4 to 4. So see here the element 2 is associated 2 times. So the element 2 belongs to 2 as well as 4. So here the element 2 has 2 association. There is no unique association for the element 2. So therefore this F from A to B is not a function. This is not a function. This is not a function. See here there are 2 association for this element 2 in the set A. The element 2 of the set A is related to 2 and 4 of the set B. So therefore F from A to B is not a function. How to put it in the mathematical form? The element 2 of A has 2 images in B, namely 2 and 4. Therefore F from A to B is not a function. How to explain? The element 2 of A has 2 images 2 and 4 in the set B. Therefore F from A to B is not a function. That's it. Now let us come to the third one. Straight away you can say 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5, 5 comma 6 and 6 comma 7. There is only unique association. All the elements of the domain are uniquely associated with the elements of codomain. Therefore we can say that this is a function. This is not a function, whereas this F from A to B is a function. This is also a function. If you want, you can represent in a diagram. So by looking to the problem, you can say that 1 comma 2, 2 comma 3, 3 comma 4, 4 to 5, 5 to 6, 6 to 7. That is, all the elements of the domain are associated unique time by the elements of codomain. Therefore, this is a function. F from A to B is a function. That's it. So here the first one is a function, second one is not a function, and third one is also a function. That's it. Okay. Now let us come to the next problem. This is very simple problem. What is the problem given? Let n be the set of natural numbers. Define a real valued function f from n to n by f of x is equal to 2x plus 1. Using this definition, complete the table given below. Now we have to complete the table here. Very simple. Just what is given? F of x is equal to 2x plus 1. This is given. Now find out the values of f of 1. Put x is equal to 1. You will get f of 1 is equal to 2 into 1 plus 1, that is 3. So here the value of f of 1 is 3. Now if you put x is equal to 2, if you put x is equal to 2, you will get f of 2 is equal to 2 into 2 plus 1, that is 4 plus 1 is equal to 5. The value of this is 5. Similarly, put x is equal to 3, f of 3 is equal to 2 into 3 plus 1, 2 3 is 6 plus 1 is 7. And similarly, if you put x is equal to 4, f of 4 can be written as 2 into 4 plus 1. That's equal to 8 plus 1 is 9. Okay. Again, when you put x is equal to 5, what you will get? 2 into 5 plus 1. That's equal to 11. Similarly, if you put x is equal to 6, 2 into 6 plus 1, 12 plus 1 is 13. So if you put x is equal to 7, 2 into 7 plus 1, that is equal to 15. Just here, for all the values of function is increased by 2, that's it. When x is equal to 1, f of 1 is 3. When x is equal to 2, f of 2 is equal to 5. When x is equal to 3, 5 plus 2, 5 plus 2 is 7. Again, when x is equal to 4, 7 plus 2 is 9. When x is equal to 5, 9 plus 2 is 11. When x is equal to 6, 11 plus 2 is 13. Again, when x is equal to 7, 13 plus 2 is 15. So, f of 1 is 3, f of 2 is, so therefore we can write, therefore f of 1 is equal to 3, and similarly f of 2 is equal to 5, like that, and the last one is f of 7 is equal to 15. The function of 1 is 3, and similarly the function of 7 is equal to 15. That's all. So this is how we are going to fill the table, just finding the value of the given function. That's it. Just put x is equal to 1, 2, 3, 4, 5 and 6. You will get these value and substitute in a table. That's it. Okay. Now let us come to the next set of problems. Now, which of the following relations or functions give reasons if it is a function, determine its domain and range, same as that of the previous problem. Now let us come to the first one. Now here straight away you can see 2, 1, 5, 1, 8, 1, 11, 1, 14, 1 and 17, 1. Here let us consider these are the two sets. So suppose if A contains 2, 5, 8, 11, 14 and 17, this contains only one element. So 2 to 1 they are mapped, 5 to 1, again 8 to 1 and 11 to 1, 14 to 1 and 71. So this is A and B. Check whether this is a function or not. F from A to B is a function or not. Just check. By looking to this arrow diagram, you can straight away say that this is a function because this is a domain and a codomain. So you can straight away say that every element of the domain is associated with a unique element of codomain. So that is, every element of the domain is used only one time with the element of the codomain. So therefore, f from A to B is a function. We can say it as a function. See, 2 to 1, 5 to 1, 8 to 1, 11 to 1, 14 to 1 and 17 to 1. So all the elements of the domain are unique association with the codomain. That means each and every element of A is associated with unique time the element of the set B. Therefore this is a function. Every element of domain is uniquely related with the element of codomain. Therefore this is a function. So first one is a function. Now let us come to the second one. See here also 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6 and 14, 7. So here also all the elements of the domain are uniquely associated with the elements of the codomain. Therefore this is also a function. So f from A to B is a function. This is also a function. Now let us come to the third one. See here, if you come to the third one, this is A and B. What is A contains 1 and 2, B contains 2, 3 and 5. How they are mapped? 1 to 3, again 1 to 5, again 2 to 5. So here definitely we can say f from A to B is not a function. This is not a function because the element 1 is related. This is the domain and the codomain. The element 1 is associated with two elements of the codomain, that is 3 and 5. Therefore this is not a function. Now what is to write? Write, determine its domain and the range. Now this is the domain. The domain of this function, is equal to domain of f is equal to the elements, first elements 2, 5, 8, 11, 14 and 17. These are the domain. So this is called the domain. And what is the range? This is called the range. These are called as the range. the range is equal to 1. So the elements of set A are called as the domain, and the elements of the set B, the used elements, are called the range. That is, here 1 is the range. So if we come to the second problem, here the domain of this function, domain for this is, the domain is 2, 4, 6, 8, 10, 12 and 10, 12 and 14 is the domain, whereas the range is equal to set of all second elements 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 and 7. This is the range. That's it. See, listen to me here. So for this, the set of all first elements comes under the domain. The first elements are 2, 4, 6, 8, 10, 12, 14 is the domain. Whereas the set of all second elements, that is 1, 2, 3, 4, 5, 6, 7 comes under the range. So here also the domain is 2, 5, 8, 11, 14 are the domain, whereas the range is 1 is the range. Here for this example, first elements are the domain and the second elements are the range. Since this is not a function, we won't get the range and domain for this. Okay. Now that's regarding this problem is concerned. Hope you followed. Now let's come to the next problem. Find the domain and range of the following real functions. So here the modulus function is given, f of x is equal to minus of mod x, and here f of x is equal to root of 9 minus x square. So let us come to the first problem. What is given? F of x is equal to minus of mod x. So here f of x is equal to minus of mod x, where x belongs to x. Find the domain and range for the following real function, set of all real values. So which implies f of x is less than or equal to 0 for all x belongs to R. F of x is less, minus of mod x is, so minus is nothing but less than or equal to, so the function is less than or equal to 0 for all x belongs to R. So therefore the domain of f is equal to R. Domain of f is equal to R itself. The domain of f is equal to R. Now then we have to write the range. Now therefore the range of f is equal to minus infinity comma 0. Minus infinity comma 0 is the range for this function. That's it. Now come to the next one. So what is given? F of x is equal to square root of 9 minus x square. Square root of 9 minus x square. That means f of x is greater than or equal to 0. Here f of x is greater than or equal to 0 means that is nothing but 9 minus x square is greater than or equal to 0. 9 minus x square is greater than or equal to 0 means, which implies x square is less than or equal to 9. That is nothing but 3 square. So that means the value of x lies between 3 square means that is nothing but minus 3 less than or equal to x less than or equal to 3. That's it. So therefore the domain is equal to, domain of f is equal to minus 3 comma 3. Minus 3 comma 3 is the domain, and the range of f is equal to, the range of f is equal to 0 comma 3 is the range. That's it. So the range is the closed interval 0 comma 3. So here, since f of x is equal to root of 9 minus x square means f of x is greater than or equal to 0 means 9 minus x square is greater than or equal to 0, or x square is less than or equal to 9, that is 3 square. That means x lies between minus 3 and plus 3. Therefore the domain of f is minus 3 comma 3 and the range of f is equal to 0 comma 3. That's it. Closed interval. Now let us come to the next problem. Now what is the problem given? A function f is defined by f of x is equal to 2x minus 5. Write down the values of f of 0, f of 7, and very simple problem. This is what is given here. Given f of x is equal to 2x minus 5. Now put x is equal to 0. Then you will get f of 0 is equal to 2 into 0 minus 5 is 0 minus 5 is equal to minus 5. So therefore f of 0 is equal to minus 5. Now let us come to the second one. Put x is equal to 7, then you will get f of 7 is equal to, put 7 here, 2 into 7 minus 5. 7 2s are 14 minus 5, this is equal to 9. The function of 7 is equal to 9. That's it. Okay, now the final one is put x is equal to minus 3. If you put x is equal to minus 3, you will get f of minus 3 is equal to, put x is equal to minus 3 is 2 into minus 3 minus 5. This is minus 6 minus 5 is equal to minus 11. Therefore, f of minus 3 is equal to minus 11. That's all. So, here function of 0 is minus 5, function of 7 is equal to 9 and function of minus 3 is equal to minus 11. That's it. Just put the value of x. Put x is equal to 0, 7 and minus 3 in the given equation 2x minus 5, you will get the answer. That's it. Very simple problem. Now, let's come to the next problem. The function t, which maps the temperature in degrees Celsius into temperature in degree Fahrenheit, is defined by T of C is equal to 9C by 5 plus 32. Find the values of T of 0, T of 28, T of minus 10 and the value of C when T of C is equal to 212. Now, very simple problem and important. What is given? T of C is equal to, the given condition is 9C divided by 5 plus 32. Now, put C is equal to 0 first. Then we will get T of 0 is equal to 9 into 0 by 5 plus 32. This is 0 plus 32 is equal to 32. So, therefore, T of 0 is equal to 32 is the first answer. Now, come to the second one. What is second one? Put T is equal to 28. If you put T is equal to 28, T of 28 is equal to 9 into 28 divided by 5 plus 32. Simplify this. That's it. So, if you simplify, take LCM, 2 is the LCM, 5 is the LCM, 9 into 28 plus 32 into 5. On simplification, what is this? You are going to get substitute. Now, if you multiply 9 into 28 is nothing but 252 plus 32 into 5 is 160 divided by 5. So, this is equal to 160 plus 252 is equal to, divide this. So, if you divide 412 by 5, you will get 82.4. So, this is 82.4. So, therefore, T of 28 is equal to 82.4 is the second answer. Okay. Now, let us come to the third one. What is the third one? Put T is equal to minus C is equal to minus 10. If you put T, C is equal to minus 10, 9 into minus 10 by 5 plus 32. See here, this is 5 2s I gets cancelled. So, then what you will get? So, 9 into minus 10, that is 9 into minus 9 2s are 18, minus 18 plus 32. Minus 18 plus 32, you will get the answer. Now, what is the simplified answer? This is equal to 14, that's all. So, this is 14. The answer for this is 14. So, therefore, T of minus 10 is equal to 14. That's it. See here, put C is equal to 0. This becomes 0 plus 32 is 32. Put C is equal to 28. 9 into 28 plus 5 plus 32. Take LCM. 5 is LCM. So, 9 into 28 is 252 plus 32 into 5 is 160. That is 412 by 5 is 82.4. So, T of 28 is equal to 82.4 Fahrenheit. Now, when T is equal to minus 10, put T is equal to minus 10, 9 into minus 10 by 5, 5 2s gets cancelled, 9 2s 18, minus 18 plus 32 is 14. So, T of minus 10 is 14. Now, finally, what is required to find? Find the value of C when T of C is equal to 212. Now, I will write here, given T of C is equal to 212, then what is the formula here? T of C is equal to, we have T of C is equal to 9C by 5 plus 32. Now, what is required to find is C. This is given 212 is equal to 9C plus 5 by plus 32. Transfer this, 212 minus 32 is equal to 9C by 5. What is this equal to? 180 is equal to 9C by 5. Cross multiplied, 180 into 9 is equal to 9C, or C is equal to 180 into 5 divided by 9. So, C is equal to 9 2s are 20 into 5. This is equal to 100. So, C is equal to 100. That's it. Okay. So, this is how we are going to solve. See here, T of C is given. T of C is equal to 212. What is required to find is C. Now, what is the relation? T of C is equal to 9C by 5 plus 32. 212 is equal to 9C by 5 plus 32. Just bring this to the left hand side. 212 minus 32 is 180 is equal to 9C by 5. Cross multiply it. 180 into 5 is equal to 9C, or C is equal to 180 into 5 divided by 9. 9 2s are, that is 20 times gets cancelled. 20 into 5 is 100. So, C is equal to 100. So, when C is equal to 100, T of C is equal to 212. Hope you followed this. So, this is very simple and important problem. So, these are few problems based on the functions. So, that's all regarding today's session. Let us meet with different type of problems on functions in the next session. Thank you. Thank you very much.